All right. Hello, everybody. I have a little project here. I received. Let me open my lights a little bit. I received a couple of components. Well, in time, of course, but now I get to use them. What this project is about? Nothing is soldered here, so everything is in air, in a sense. So this is a PIC12F508 microcontroller, and nothing is soldered. I'm just making the plans right now. This is an RGB LED, which I'm not sure if you can see it. Not that not that good. Let me. So this is the RGB LED. I hope you can see it. Yes. And it's a very strange. Yeah, this is good. So do you see the marker here, the triangle, the white triangle? Usually that is a minus sign, and it's having four pins, as you can see, and it's a tiny RGB LED. It's the same there as well, if this is focusing right. Okay, so I I put 4 wires on it, and I made a test because it's a very weird comparative with the classic RGB LED or with the classic LEDs. Is having a plus sign, well, contact there, opposite to the minus triangle, and on everything else is minus, but that corner is, that pin in that corner opposite to that triangle is the plus, is the common plus or positive voltage. It's kind of working on 5 volts. I blew up one LED because the red LED yes, so pizda mati focus and meta. So do you see how fucking small this thing is? So I have to deal with this, but this is not the small one. The smallest one, check this out. And probably that's why I'm crazy. That's why I want to build this thing. Do you see this little component here? It's having even smaller pins on it. Let me actually put it on my finger here. I'm not sure if you can make the difference. Probably if they are close together, it's better to have them close together, I suppose. I'm not sure how. Can I do it with one finger? Yes, I did it. So this is a resistor pack of 1 kilo. And do you see those pins are a little bit tinier than the pins of the capacitor? And it's just, wow, it's just super difficult to get there with my iron tip of the iron. So that's a challenge. It's a very challenging problem to resolve. Also these LED wires and how I will make everything. I mean, how I will link everything, but I will explain. I will explain it very quickly. So let me rearrange everything back as it was. So what I'm doing right now is called in air. I am building in air. As I'm putting, do you see here on the schematic? This 10 kilo is that, and from here, yeah, I will get from this guy. So pretty much, so I have these little boards. Actually, I will show you here. This is a case from pills that my father is taking these pills, and it's a box, and I took the box and I made my box for these things. And it's perfectly fit, and yeah, it's pretty good. I really like it. Yeah, you see, this is for blind people, the points, and yep, it's a pretty box. I really like it. So I bought these boards, these prototyping boards, board adapter they are called, and they have two sides. So it's having this side that I'm putting my microcontroller, perfect for my microcontroller that I have right now there, and so this is the side, that side. But if I'm flipping it, I'm getting even smaller pads for other special microcontrollers or chips. I really don't know those. So as you can see on this side, where the larger pads, and they are not that large, but the larger pads are so on these large pads I will put my microcontroller, as you can see. But on these little pads, I have to work with my left hand right now, which I'm not very. So this is the idea right now. So I'll put this little guy here. Everything that I'm explaining right now is I cannot put it perfectly on position, but trust me, I did the planning. Everything I'm showing you now, this is the preparation, how it will go, how I will manage to make it with all these super tiny pins that I have on these components, on these special components that nobody is using them. For example, this 8-pin resistor pack, I took it out from two possible places, from a RAM or from a motherboard. I took out a lot of components, and this button is actually from a board from cellular mobile phone. This is a button from a mobile phone that I scrap for parts. And this is a new resistor, this is a new resistor, this is also a scrap resistor probably, though that capacitor is also a scrap capacitor. The microcontroller is brand new and the boards are brand new. But yeah, my time is up, 1 second. So these two sides are actually mirrored. This side with this side, when it's flipped like this, horizontally flipped, I have to do everything with one hand. They are corresponding, these pads here. So not the circles, only the long pads. They are corresponding when it's flipped the other side. And this is what I actually draw here. I tested everything. Unbelievable. So this is what my drawings here are showing. But first of all, I'm sorry to jump from one subject to another. I didn't plan. I'm just free talking, and when I'm free talking, I'm just not good on explaining everything. It's so much to explain. So so this is the circuit of the PIC and all these components. So this is the basic circuit, and then I draw two boards. So first board here and the second board here. What this means, it means so this board is the larger pads, and this board is with the smaller pads, and is from the other side, from beneath this one for this one with larger pads. This is the side with the smaller pads, and this little thing here is the 8-pin resistor pack, which will be a pain in my ass to deal with. This is a 10 kilo resistor, and which is this one, this big one. Come on, be cool. So a close look on the circuit schematics. I have 1 kilo, 1 kilo, 1 kilo, and 1 kilo here from GPU tray to this pad. It says here 1 kilo for this one, and the 10 kilo from pin 1 of the chip to this pad, and then to from this pad to this pin of the button, and from this button going to the minus pin, which is in top here at the top. And here is the capacitor between these two pins, and this is the RGB with all the minus tracks, and only one common plus track there. I actually tried you know, probably that was the idea of a common plus track. This chip is wrong, is very wrong. is just stupid, but it's working. I managed to make it work. I mean, yeah. I like its size. The size of it, I really like it, because it's very small, and yeah, it's cool because of that. So I actually tried with only one resistor on its plus, and all the minuses going to the pins directly without this 1 kilo resistor on them. And yeah, it's kind of working, but it's not working at full potential. Is not creating the white light, which is not that white. That's why these RGB LEDs are a bit crappy, but they are usable for what I want to do with them, which is very extremely basic things to do. I want to do with them, very basic. So it is necessary to add this extra 1 kilo, because it will give the full range of colors and brightness, the full brightness of colors and colors, the full brightness and colors. So that's the story of this little. So I have 4 1 kilo resistors, 1, 2, 3, and the fourth here. And this little resistor pack, I don't know how they are called actually, and they, believe me or not, there are, just to compare it again with my finger here, they are even smaller than this. This is a big, this is, trust me on this, they are smaller as, holy shit. So I cannot explain to you. Yeah, this is good, like this small, with fucking 8 pins on them. Can you believe me? So I have some of them. I don't have them on my table right now. I have to search for them, but trust me, I have those extremely, just crazy small. It's practically only with a robot you can solder them. Manually is almost impossible. It's almost impossible to solder this guy manually. Right now, I have no idea. I only solder them. I never solder. Never try. This is the first time when I'm trying to solder this resistor pack of 1 kilo per branch. And yeah, it's exactly like I have here in my circuit diagram. And here is how it is looking on the board. So this is the other side of the here where the larger pads are is the programmer, the chip, the PIC, microchip PIC. And on the other side is this little resistor pack here somewhere, and all these pads are corresponding to these pads. So even if I'm putting it on the other sides, these little pads are corresponding exactly to these pads on the top, and my resistor is actually communicating with these pins. And here it is more I didn't finish actually explaining all of this. So this is the plus, as you can see. This is a capacitor here between minus pad and plus pad. I couldn't put it here like in schematics between these two pins. I put it like that up because it's correct. It's okay. It is a track there somewhere. This is the button, that button, and let me point with something else, not with two. And this is a pad here. This is this pad from the schematic. This is the pad, a large pad that will link this button pin, this wire that is going under, and is exactly this wire here that is going to the fourth resistor in that little pack, and from here is going to pin to GP tray. These are GP0, 1, 2, GP3, GP4, GP5. So from GP3 here is that 1 kilo, but through this wire and like this and going this and here. It's a bit of a mess, but and from here is to minus. So this is the link to the minus in the circuit diagram, but here in the on that board, from here to here is the minus, and that's it. And that's one difficult thing with this resistor pack. And this is how I connect the resistor pack. I think I will cut these wires. I will have to prepare this. I will not leave it intact. So I will actually, where are you? I will cut between them, and I will link my my resistor pack from this side to this side, and I will obliterate, I will erase totally this first track because I'm afraid of making contacts, and I don't want that. And so I will leave only these three. Actually, it will be in this side of the chip. So only the lower 3 pins and the upper pin I will obliterate it. I will take it out from the board. Come on, don't fuck me now. Hai du-te în pula mea. Hai în pizda mă. Okay, so back to, so that's how I plan. Like I said, this is the plan. I spend like half a day, well, a couple of hours of planning for everything, thinking on everything. Let me. Now the other another problem I have to resolve is this LED. How the hell will I really right now when I'm filming? So this will stay there, everything. So right now I'm putting on the position like it will be ensembled, because it's very easy to visualize how everything will go there. And this guy here somewhere, and that one. Actually no, these guys I will not need them. These two semi-LEDs, I was considering them, but I chose in the end that one. Or probably I will go with a semi-LED. Who knows? And get rid of this big resistor. Then another problem is how I will integrate and link this RGB LED. And I have two options that I thought of, two versions. I will elongate the plus and minus tracks from this circle pads, from here and from here. So actually from this one. So from here and from here, I'll put a longer bars for plus and minus. Okay. And as you can see here, so from this point and this point, I'll make a longer bars like here. This is the RGB LED that is linked to the plus, its pin, and then the rest of the pins to the resistor pack. And here in these two versions, I have either to make I'm thinking to mold plastic, to mold a plastic around this chip, and the height of this chip is actually as high as this board. This board is actually two boards. I'm not sure if you can see it. Can you see it? Let's see if you can see it. Come on, concentrate there. No? Are you? No, it cannot do it. Yes, that's it. You see there is a white line between it. So this is actually made from two boards, and it's pretty thick, and that LED is kind of the same height as this thick board that I have here. I will practically melt some plastic around. Like, do you see this little not square, but yeah, let's say like a box or square. I'll call it square around the semi-LED LED, the semi-LED RGB LED. So this is that square around. This is the board, and this is how is viewed from the top. The full, so under this board and following a little bit more outside, where I press, or where I mold the square of the RGB LED there. So this is the case. The first case one is when it is all full of plastic, or molded into plastic. Actually, I will pour plastic over what is here and that LED there. Or the second version, when I will make only this little board, square box with the LED inside and its connections and the bars, like I call them bars, the the plus and minus bars, not bars but tracks, and they will offer a little bit of strengthening. If it's only this little plastic thing, but what I really want is resistance. What I mean is strength. The entire board, I want it to be safe to touch and safe to manipulate. When I will put my fingers and keep it with my fingers, because it's tiny, it's quite, it's tiny and it's fragile. All these components, the soldering will be especially this output here with these 3 wires to the LED, it will be extremely fragile, these connections here. So this is my entire full plan for this project. I almost forget. I have this connector that I will have to link wires to all these pins, to GP4, to GP1, to GP0, to minus, to plus, and then to GP3 from this connector. And this connector I will have to plug it in my PIC programmer. So these wires from this connector I will link. This connector I will link with wires to each of those pins, and that's why I initially I choose this little board to use it. So I will link. I have actually, you can see it here. I have enough space to link those wires that will go to that connector outside. And when everything will be programmed in this PIC microcontroller, I will disconnect, I will desolder the wires, and I will leave this intact. And someone else, if will want to reprogram this PIC, he can reprogram it, but he will have to, or I will have, because I am the the owner of it, and I will have to relink those wires. But it's an interesting way of doing things, and that's this project is definitely out of my comfort zone, definitely, especially because of those extremely fragile and tiny links that I have to make. It's just yeah, well, that capacitor I don't count it, because I did made with very small components. I did make already some boards, but this is a very special board. Is having some very intricate and very problematic areas to make, zones to make. Is having many problems to resolve. So that's fucking hell. So yeah, that's get back there with one finger. Do you see how much dexterity I have from all the games I played when I was younger? So yes, yeah, I hope I will make this a reality. I forget to mention that I already tested this LED with all these wires on it. I tested on my programmer board, and I put Deep 8. It's that chip that is not a semi-day, is a true hole. It's having longer pins, And with that DIP 8 pin, no, not pin, chip, microchip, already was programmed. And when I put this LED, that you can see it here, when I put it there, I only tested one plus and one minus to see if at least one LED will open. And I get lucky to test the blue one, which is like 3 volts or more. It worked at 5 volts on that board, but here when I tested, my red LED got burned. Not in this, in another one. And I changed all the wires again. But the rest, green and the blue, they were resistant to 5 volts. But I don't want to risk it. I'm putting this 1 kilo, so it's safe. So this is the test I already made with this LED here, and is working as it is, as weird as it is. These connections, all the 3 minuses output and 1 input from the plus. This is just fucking weird, but I managed to make it work with my PIC that I have already installed there, and with its program that is blinking 1 LED. Actually, I pressed the button and I've seen that LED open for a very short time, and it was actually it was inversed. Because all the pins on the microcontroller that I already have there was keeping the light on all the time, and when I pressed, it was turning it off. But in reality, is inverse. Is keeping everything off, and when I press the button, is bringing on, lighting a LED. So, but this is opposite from that, but that code is easy to make, is not a problem. So yeah, that's the full story of everything that I have here, of this plan. And yeah, we'll see how will come out. I just wanted to show you everything, and I hope you like it. And let's hope I'll make it. Let's hope I will make it. All right. Thank you very much for watching, and see you later. Hopefully on the next movie when everything is already done. So this is the programmer board that I have already, and when I'm pressing this button here, you see it. This button here, I'm pressing, that LED is turning on, and that is the PIC12F508 DIP 8. It means dual in package with longer pins. It's the bigger brother of the CMD. So when this is the first LED, and immediately there are 4 LEDs, as you can see. Yes, 1, 2, 3, 4, 5. And the second LED, one is off, this is on. When the second LED is on, this is off. So when I'm pressing the button, you see, click, 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 click. But this is because the polarities are inversed. But it is working. I'm testing only 1 LED from this RGB. I didn't put through 1 kilo resistor there, so it's not maximum bright, but it's bright enough. It's doing something. And this is almost floating here. This plus connection that I made here, it's very wibbly, but it's good enough. It's working. So with that PIC microcontroller already programmed, I could test this RGB LED that is a weird, very weird connections it has in it. So yes, that's it. That's what I wanted to show you about this. That the probe works in the testing. Is working in the testings, and the code in the PIC I can inverse it anyway, anytime, to be off all the time, and when I'm pressing to bring it on, like exactly like is the LEDs, the red LEDs on the testing board here. So yes, that's it. Thank you very much.